Hello and welcome to another video. In this one, this one's going to be a little bit different. I'm actually going to show you some of the techniques I've shown in previous videos, but we're looking at a bug in pytest, a regression in performance, and how I tracked it down to some pathlib stuff, as well as some caching issues, and a fun little falsey bug. So I'm going to show you a few techniques that I used to find this performance regression, and also show you what the bug was and how we went about fixing it. So let's jump into it. Okay, so the performance regression was between the currently released version of pytest, which is 6.2.5, and the pre-release of pytest 7, which has a bunch of breaking changes, so we've been trying to take it as slow as possible and avoid breaking the whole world. But we noticed, or well, we didn't notice, one of our consumers noticed that there was a pretty big performance regression in the latest version, mostly just based on Twitter, and an almost 2x slowdown. And, the thread went back and forth. I didn't jump into thread until later. There was some profiling here. The profiling was not actually that helpful given the stuff that they were using here, but I'm going to show you the profiling tools that I use. I've actually done a video on this as well, so I will link those in the description, but a bunch of profiling. And the important part here is we found some packages that were significantly slower, and I'm going to actually use this package here to demonstrate that issue and then walk you through how I found what the problem is. So first, let's find this package on GitHub. I don't think it's that one. Which one is it? This one. Oh, maybe it is this one. Okay. Yeah, Python node semver. Okay, cool. So this is the package we're going to start with. Git clone that. And we are going to set up two virtual environments. One for pytest 6 and one for pytest 7 to show the difference between those. VM6 bin pip install pytest. That'll just get us the latest 6.2.5 version. And in VM7, we're going to install with the -- pre flag. The -- pre flag is going to install the latest pre-release version here, so we get pytest release candidate 1. Of course, if you run this, you might get a newer version that has this fixed already, but release candidate 1 continues to have this bug. Okay, and if we look at pytest node semver, let me see if it has any dependencies. I don't remember it having any. Yeah, we don't have any dependencies, so we can just very easily run pytest directly here, and I believe this is how I ran the test before. Oops, vn6 bin python. There we go. And we can see for pytest 6, it takes 1.2 seconds, and if we look at pytest 7, it takes, it seems a little bit slower. It takes 4.3 seconds, so it's a lot slower between 6 and 7. And so that should make it pretty easy for us to figure out what the performance problem is. So the first thing that I wanted to do here is profile it and see what is taking most of the time here so that we can kind of at least get an idea of where we should be looking when we try and figure out what caused this regression. And for that, I'm going to use a C profile. And this is the same tooling that I showed in the profiling video, which I, again, will link in the description. Profile, and this is just a command that I happen to know, -m pytest. Nodes. Okay, so we're going to use the C profile module. We're going to have it output a pstats file. This will represent the kind of binary sum data of all the functions that run, and then we're going to run pytest against node semver. So if we do this, it should run, and we'll get the same slow 4.5 second output, and it'll point us, it'll spit out this pstats file. So we see we now have this log.pstats, and there's a bunch of tools which will ingest this. We are going to use a tool called gprof.dot 7 bin pip install, and I'm going to be using the Yelp fork of it. Yelp gprof dot gprof, I can spell. And this is a package that I've contributed to. I've shown this package in that other video as well. This is all kind of rehash of that. And then if we do bin gprof.dot, take in that pstats file, and then use dot, output as an SVG, we should be able to, oh, we need -o. Yeah, I know how to use this tool. And then we can open up that SVG using the browser and take a look at where the performance bottlenecks are. So if we zoom out a little bit, you can see that it's a pretty sprawling graph. I can actually narrow this down a little bit by using some of the options to gprof.dot, because there's a whole bunch of nodes here and we don't actually care too much about it. So there's some name error if you don't press the arguments. I guess there's some bugs in it that could use fixing. But yeah, if we do -e and -n and pick numbers that are bigger than this, we should get a more simplified graph. So I'm going to use 1 and 0.5 to hopefully get it slightly less. So -e of 1 and -n of 1 and -e of 0.5. That should make this graph a little bit simpler, so we can hopefully get a better view of what's going on here. And generally the way this is structured is it's colored based on the things that are most expensive. So we see this red part here, this is the most expensive part. Now I'll save you the looking through this and figuring out the actual slow part, but it happens to be this bit of code right here, this iHook, nodes iHook, which is some part of pytest that does some stuff. And you'll notice that it calls this get hook proxy and calls this get conf test modules. And you'll see this is called almost 20,000 times. So nearly 10,000 times, or sorry, 20 times per test. You can see we ran about 1,000 tests, so about 20 times per test, which is not great. We probably don't need to be calling this very often. And you'll notice that all of the stuff under it is just a bunch of pathlib. And even this is part of pathlib. This is a little bit sneaky here, but it's part of the pathlib parents module or attribute of paths. Now I only know this because I looked into it, and I'll just save you that investigation here. But this is all pathlib here, and it's taking almost 65% of the execution of our runs. And I could do the same profiling for the old pytest. I'll skip you that time. But this function in pytest 6 takes such an insignificant amount of time that it doesn't even show up on the profile graph. So we basically went from 0 to 65% of our execution inside of this get conf test files, or get conf test modules thing. So, okay, at this point, we've been able to reproduce the problem. We kind of have an idea where the problem is, but now let's try and figure out what caused this and how we can fix it. So for that, what I'm going to do is I'm going to bisect the change. I did a video on bisect, so I'll link that in the description as well. But we're going to try and use get to bounce around through the revisions and find the first one that makes this slow. And we're going to clone pytest to do that. And I'm going to set up a virtual environment inside pytest, and we're going to use this test suite to figure out which is slow and which one's fast. We know in the fast situation that it takes about 1.3 seconds, and we know in the slow situation it takes about 4 seconds. So we're going to use a tool called timeout, which allows us to run a command with a duration and kill it if it takes too long. And so we'll pick some number between 1.3 and 4, and that'll allow us to differentiate between a good revision and a bad revision. And that's the most important part of bisect. So now that we're in pytest, and I'm going to make a virtual env in here, and we're just going to install, oops, great if I could spell. We're going to install ourselves. That way we are testing this. I'm using editable mode. That way we don't have to continually reinstall every version that we check. It should hopefully short circuit that a little bit. Although I think we also need to do pip install toml to make that work, because I think we switched the toml library between the two. I don't know. We'll try that. If it doesn't work out, we'll do a full install. All right. So next we need a script that is going to tell us whether we succeed or not. And I'm just going to make a very simple bash script. And this will look very similar. I actually have one in this issue here, so I'm just going to remake another one that's very similar. And what we need to do here is we need to run the test suite inside this other repository. We need to cd into here. And we need to run with timeout some amount of, we need to run this test suite and make sure that it passes. So we are going to use duration there. So we're going to do timeout. I'm going to use 2.5 seconds. That seems like a good middle ground between 1.5 and 4. And I actually had to fiddle around with this timeout value when I did this myself. Like I initially tried 2 when there were some false positives. Like sometimes it was just lower for unrelated reasons. So we're going to use timeout 2.5, and then we're going to do pytest, or we'll do python-m pytest. We have to do some fiddly syspath stuff. And this is the thing we are testing. And timeout is going to return particular exit code. So it returns the signal that it kills it with. So normally it's going to return 124 or 137 if it's done with sigkill. But get bisect needs it to return 0 or 1. So what we're going to do is do or exit 1. And this is basically just going to make it so that we have a consistent exit code when the timeout fails. Otherwise, it'll exit 0. Some other stuff you would maybe have to do with bisect, but I didn't have to do here, is if you have some undeterminable case, so say there was like some syntax error in pytest or some other thing, you would exit a different code for bisect. I don't remember what it is, but I go over it in the bisect video, so check that one out instead. We're going to make this executable, and we're going to start our bisect process. We're going to do get bisect start. We need to mark the old revision as good, so we're going to do get bisect good 6.2.5. That'll say that this was the good revision, and then we need to get bisect bad 7.0.0 RC1. Cool, so now we're ready to start running our bisect, and it's just going to run this script over and over and try every commit till we find the bad one. And hopefully this works. Get bisect run ./t.sh. Should hopefully work. Okay, so now it's just going to keep trying revisions over and over and over. See that it runs the test suite a bunch of times. These ones are all, whenever we see this output here, then it succeeded. Here's one where it timed out, so it didn't succeed here. It crashed. The timeout thing stopped pytest from running, and we got an exit 1. So this, we know this was one of the bad commits, and it's just basically going to keep doing that back and forth until it narrows down the commit that was the problem. And you'll see here that it actually did that pretty quickly, despite there being, what, several hundred commits between the two? What did it say up here? Doesn't tell us how many. A merge base must be tested. Usually it tells you about how many commits it's going to do, but I think, let's see, it did 1, 2, 3, 4, 5, 6. It did about 500 or 600 commits between the two, and it resolved it very quickly and found us exactly the commit where the performance regressed. So this tells us exactly what commit that was, and we're going to look at that in our browser here, take a look at why that commit changed. Pytest dev pytest /commit/this, I think is the URL. Yeah, so avoid LRU cache on methods. So this removed a caching portion of pytest, and we'll actually open up that pull request, take a look at it in a second. But you'll notice that one of the functions that it removed LRU cache on is the get conftest modules. And if you remember back to here, that's our function that's taking 65% of our time. So removing this cache caused our performance regression. We found exactly why it happened. However, if you look at the PR, you'll notice that there are two commits. The first one is to remove the LRU cache, and then the second one is to optimize this function to avoid the performance regression, because removing the cache obviously causes the performance regression, and so we'll fix that up with the second commit. And so if we go here and try and check out that second commit or show what this is, I guess we can just show it in the browser. There is a slight bug in here that avoids, this is supposed to avoid the rest of the function from running, but if you look at the profile, you'll notice that all of this is still running. We're still getting this this expensive contains, which comes from this call right here. That is the contains. Actually, it's here. This is the contains call, and we're still seeing all this other pathlib stuff happening. So clearly, this short circuit is not working. And if we look closely at it, there's a nullability, a truthy falsey bug here. This is our cache of return values here, this dir path to conf mods attribute. And the way the short circuit code is working is if we found an entry in here, or at least that's what it's supposed to be doing, then we will just short circuit and return that value directly. However, the problem is this function here, get conftest modules, oops, too far. This get conftest modules returns a list, and sometimes it can return an empty list. And when it returns an empty list, this will be the empty list here, this will be the empty list here. If empty list is false, so it skips our short circuiting code and continues on through the rest of the function here. And so, a little truthy falsey bug here made this performance optimization not work. And in fact, if we go in here and add that performance fix, so you can check out 7.0.0 RC1, and we do source source underscore pytest config init get conftest modules. Need the function definition, and here is that short circuit code here. And if we change this to is not none, which is the correct check for whether this, because get will return none if it's not there. This will fix our performance bug, and if we run our script now, or t.sh, you'll see that we pass our timeout here. We're able to succeed. Now note this is still slightly slower than before because it is still running some pathlib code before here. And we've decided for now that this is an acceptable performance regression. It's only about 15 to 20% slower rather than 200 to 300 to 400% slower. And we'll look for other ways to optimize the performance of this function, but it is no longer a release blocker because of that. Cool. So yeah, basically this video, I wanted to show you, a performance tool that helped me identify where the problem was. I used bisect to identify which was the first commit that caused this problem. And then I showed you a neat little bug from a truthy check here. And of course, be careful when you use pathlib a lot because it can slow down your program. And this is another situation. Oh, actually, I did another video on pathlib being slow, so I will link that in the description as well, where I found a 40x performance problem in black due to pathlib. But anyway, that's what I want to show you here, and we did eventually figure out the performance issues in the same way. You can see this is basically the same performance stuff that I figured out here. I figured out a patch that reestablished this cache, and I'm actually going to do another video about why you would want to avoid LRU cache on methods and why that's a problem, but I don't think that'll be out by the time this video is there. So anyway, hopefully you found this interesting. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.